Welcome to solverfy.
For this problem, we are given information about the production of three commodities: mining, manufacturing, and communication. And we want to find the ratio of these three commodities in a closed model. Well, first, what is a closed model? Well, a closed model is a model in which the demand is zero. Three commodities means I have a 3x1 matrix here. The demand is zero. Now, in any kind of a setup, the way we structure it is D would equal X if there was no cost associated with producing commodities. Whatever was produced would go to meet the demand. However, this is not the case. There's always a cost involved. So we need to produce more than our demand because we have to subtract out the cost associated with manufacturing. Some of what we manufacture and produce has to go back into the system to keep our productions running smoothly. Now, in a closed system, that demand equals zero. Okay, so how do we go about solving this? We're going to figure out what A is in just a minute, but how do we go about solving this type of problem? Well, first, let's do a little bit of algebra. I'm going to multiply my production matrix X by my identity matrix I. This does not change the value of my matrix. It doesn't change the value of my equation. But what it allows me to do is to do some factoring. So I can factor out an X, and what I have left is I minus A, my identity matrix, minus my input-output matrix. Multiply that by X, my production matrix, and that will give me zero, my demand. Okay, so let's write down what we have. The identity matrix is easy. It's ones down that diagonal, and everything else is going to be zeros. Okay, so that's I. Now we need A. Okay, that is going to show our input-output. Now we have three different things here. We have mining, we have manufacturing, and we have communication. And those will be across the top as well. Okay, so what are those values? Well, as we look at what is required, we're going to be going down the columns. So for what is required to produce 1 unit of mining, that's going to be down the mining column, that first column in our matrix. So 1 unit of mining requires 1/5 of a unit of mining, 2/5 a unit of manufacturing, and 2/5 of a unit of communication. How about manufacturing? 1 unit of manufacturing gives us a column of 3/5, 1/5, and 1/5. And our third column, 1 unit of communication, requires no mining, 4/5 a unit of manufacturing, and 1/5 of a unit of communication. So let's do this subtraction. As a reminder, when we do matrix addition and subtraction, we're going to be looking at corresponding elements. So let's go across the first row. 1 minus 1/5 is 4/5. Let's keep going. 0 minus 3/5 is negative 3/5. 0 minus 0. Second row, 0 minus 2/5, 1 minus 1/5, and 0 minus 4/5. And the bottom, 0 minus 2/5, 0 minus 1/5, 1 minus 1/5. Okay, so this is I minus A right here. So we need to multiply that by X. And X is our production matrix. How much of each of these commodities we produce. And we'll call those X sub 1, X sub 2, X sub 3. And we want that to equal our demand, which in a closed system is 0. Okay, I think that looks like a 0. Let's actually do this multiplication, and that'll give us a system of equations that we can solve. So cross the first row times down the first column. So that is 4/5 X sub 1 minus 3/5 X sub 2 plus 0. I'll just leave a little bit of a blank here. I like things to line up. You don't have to leave the blank. And that equals 0. Hey, second row, negative 2/5 X sub 1 plus 4/5 X sub 2 minus 4/5 x sub 3 equals 0. And our last row, negative 2/5 x sub 1 minus 1/5 x sub 2 plus 4/5 x sub 3, and that also equals 0. So there's my system of equations. Now, before I get into the algebra of this, I'm going to get rid of my fractions. You do not have to do this step, but I find it much easier to do the work and much less likely to make a mistake if the fractions are gone. So I'm going to multiply every single row by 5. That's going to give me 4x sub 1 minus 3x sub 2. And these are all going to equal 0. Negative 2x sub 1 plus 4x sub 2 minus 4x sub 3. And negative 2x sub 1 minus x sub 2 plus 4x sub 3 equals 0. Okay, looking at these equations, there are an infinite number of solutions. I can ramp production up, I can scale it back, but no matter how much I produce, the ratio of these three commodities will remain constant. So that's what we need to find here. To do that, we're going to leave one of these three variables and treat it kind of like a constant. That'll be our parameter, and we will define everything else in terms of this one. Typically, we take the last variable as our constant, as our parameter. So I'm going to do x sub 3. It's not technically wrong to use one of the other ones. You'll still end up with the same results. That's just kind of convention. Okay, I'm going to take two of these three equations. Doesn't really matter which. I'm just going to pair the last two. And I'm going to come down, just give myself a little more space. And I'm going to rewrite these in terms of x sub 3. So the x sub 3 terms I'm going to put onto the right-hand side of my equation. So here is the first one that I'm doing, and then the second one. Okay, so those are my equations. Now I'm going to take this second line and multiply it by negative 1. That way I can use the elimination method and get rid of my x sub 1s. Rather than rewrite, I'm just going to change the sign. Since everything is negative, this will make everything positive. And when I go to add these, I end up with 5x sub 2 equals 8x sub 3, or x sub 2 equals 8/5 x sub 3. I'm just going to box this so I don't lose it. Okay, now I need to take one of these equations and solve for x sub 1. Well, I'm going to go back to that first equation. It's just the simplest one out here. Again, doesn't matter which one you use, they'll all end up with the same results. So I'll take that first equation, I'm solving it for x sub 1. So I'll divide everything by 4. So 3/4 times x sub 2. Well, what is x sub 2? X sub 2 is 8/5 of x sub 3. Or if I simplify this, I get 6/5 x sub 3. Okay, so how are these related to each other? Putting everything in terms of x sub 3, my solution is 6/5 x sub 3 will tell me how much of my first commodity I need. 8/5 of x sub 3 will tell me how much of my second commodity I need. And then x sub 3 is my third commodity. So just to get rid of some of my fractions here, if I make 5 units of my third commodity, and that is communication. So 5 units of communication means I'll need 8 units of my second commodity, which is manufacturing. And I'll need 6 units of my first one, which is mining. So the ratio of these three is 6 to 8 to 5.